Welcome you again for this course Machine Learning for All. We are in module 2 and definitely in the topic 4. So here we will give you certain applications or where you can see how this supervised machine learning algorithms can be applied for various problems like regression problem and your classification problem, and the demonstration or the application of these algorithms will be demonstrated over the software MS Excel. As Microsoft Excel, this software is widely available for every student or maybe every people in their laptop or in a desktop. So this will be a very good kind of a platform to learn basically the basic algorithms of supervised learning approach. So now come to the directly the demonstration with the help of Excel. So first we will start with simple linear regression model, and then we will go for logistic regression model. So basically one for linear regression model, another for logistic regression or classification model. Then we will implement another regression and classification model with the help of KNN or K nearest neighborhood with the same platform of Excel. And later in upcoming topics or upcoming videos, you will find others algorithms, and not only and also these algorithms will be implemented in Python. So which is again mostly accepted platform or tool in for the industry, and people are definitely will be more helpful and they will get some benefit out of this course. So now straight away jump to this demonstration of this application of algorithm in case of regression problem and classification problem. Now here in this case I consider a basic data or a case data, that is you have to predict the success of a Bollywood movie. Now we have some data points available or information available for previous films. Now the case is divided into two problems. Definitely one is regression type of problem where you will be predicting the box office collection, and in the next problem you will be predicting or estimating whether that particular film is success or failure. Again we will solve that particular problem with the help of logistic regression or a classification algorithm. So now in this problem we have a data set. Now in this data set, if you just observe, total 149 data points are available. Now if I just quickly just explain the columns. So first column is movie name, and second column is budget, how much money actually spent for making the particular film. The next is YouTube views, next YouTube likes and YouTube dislikes. It may happen that right now this YouTube likes and dislike and YouTube views, they have some kind of a association between them. Still in this case we are just avoiding neglecting that association for sake of demonstration. So already I have told in my previous video that in case of linear regression we use the concept of least square error, or while we are training our model we will try to minimize the prediction error square. And finally after training we will test that model, and while testing we will measure R square or coefficient of determination and RMSE, root mean square error, for measuring the performance of our model. Now in this predictive modeling part, the training and testing, this data split has been done in the ratio of 70:30, or 70% of the data set has been kept for training the model and 30% of the data set has been kept for testing. Now for simplicity of this demo, 70% of this 149 data point that is around 105 data points has been separated as training data set, and remaining 44 data points are kept as testing data set or testing data. Now let us jump to this training. Now the thing is that this entire thing depends on the minimization of your prediction error square or sum of prediction error. So in that case, so this is kind of a simple tool. Before actually proceeding this entire activity, you have to install a tool in case of Excel. So first we have to go to the option and then you go to the add-in. Now in the add-in you will find Excel add-in, and if you hit go, so you have list of couple of tools available in the Excel. So first one is analysis tool pack, then analysis tool pack VBA, then euro currency tools and solver add-ins. So we need solver add-ins. So once you select this, check this, then you have to just click OK. And in the data tab, you will find at the end or the last column, you have this last option as solver. This solver tool is definitely used for minimizing your square error prediction. Now come to the data set. So first we have to define couple of parameters. You know the model, the model of regression is nothing but the predicted value equal to, or just I'm just mentioning again for understanding, y or the predicted value equal to intercept A plus B1 into X into X1, where B1 is your regression coefficient or weightage for X1 feature. Now here the features, so the features are budget in crores, YouTube views, YouTube likes, YouTube dislikes. These are the features or input feature for you or independent variable for your model. On the other side, you are actually predicting the box office collection. This Y is nothing but your box office collection. And the movie name, these are the nothing but the actually identity marker for the individual data points. So you have to just ignore this. This is not a feature which will help you to model. So if I just represent this entire problem with the help of expression, so definitely box office collection, which is Y, equal to A plus B1 into budget, which is X1, then B2 into YouTube views, so that is X2, plus B3 into YouTube likes, that is X3, and final feature, so B4 into YouTube dislike, that is X4. So I'm just using an abbreviation to represent the entire equation as box office collection, BOC equal to A plus B1 into budget, only B, then B2 into YouTube views, YV, then YouTube likes, YL, and finally X4 or YD, dislike. Now I'm just mentioning these parameters or your YouTube coefficient, your regression coefficients here in this cells. Remember that while solving the problem, you have to consider them as 0, because otherwise it will consider some garbage value while computing. Now with the help of these values, we will try to predict the value of predicted box office. So first is A, so you select the corresponding cell to A, and definitely you have to fix this. So you use the dollar sign, then plus the next one, that is A1, multiplied by first feature, that is budget, plus second coefficient, second feature, and third coefficient, third feature, and finally the last coefficient is M10, into last feature or YouTube dislike. So if I hit enter button, so it will predict as 0, as I have considered all the coefficient values as 0. Now what I have to do, I have to just drag this for every training data points. So all are 0. Now what I have to do, I have to find out the error and then square it. So basically that will your original value minus predicted value and take square. So once you have these values, these are nothing but your squared error in the prediction, or the square of the error. Now if I just add this, then it becomes sum of square error, and that I'm just naming as SSE. Now mind it, this value I have to just minimize. So I will put SUM, standard Excel formula, and just select all the cells. So you have all these values, right? Now we need that particular tool, that solver, to just minimize this value. Now here the first set objective, you have to select this SSC value, the particular cell representing that SSC value. Next you have to select min, already it's selected min, and you have to select by changing the variable cells. So basically we are trying to find or tune this A, B1, B2, B3, B4 value to get a minimum value of this SSC. So we have to select all this variable. Now always make sure that this box is unchecked, as you have to make these variables or these coefficient values as unconstrained, and in the solver you have to consider the nonlinear solver. And if you click on this solve, so you got the coefficient values for every coefficient, or A is your intersection, B1 is coefficient or correlation or regression coefficient for budget, B2 is regression coefficient for your YouTube views, and definitely B3 and B4 is the remaining two regression coefficient for the remaining two variables, that is YouTube likes and YouTube dislike. So now these values are the representation, or they are representing your model or your regression model, and these values is required to predict your budget values in case of your testing data set. So what I will do now here, already these values, or I have created this formula. So again in front of you I am just showing how to predict these values. So let's say I am just removing these things. these values also I'm just removing. So equal to, what happens, the same thing you have to repeat again. So you have to just select the intercept value first, and again you have to just fix it, or straight away what you can do, you can just copy paste these values. So it is better to copy paste that thing. So you copy paste these values this side, so equal to A, fix this, plus B1 into budget plus again dollar L6 into YouTube views plus into YouTube likes plus L8 into dislike. So once you again hit enter, so this is the predicted value of the box office collection based on your regression model that you have created. Now if you just drag it for all the testing data set, so these are the values of predicted box office collection for all the testing data points. Now you have to find out the measure, or you have to measure the performance of your model. So in that case you have to calculate two things, RMSE or root mean square error and R square. So before that, so what is RMSE? RMSE is nothing but the root mean square error, where you you actually calculate the average or square root of average error square. So in that case I have to just find out what is the square error. So it is same as previous. So equal to, again your original value minus predicted value, and take the square of it, and if you just drag, these are the square error. Now I have to find out the average value and then just need to take the square root of it. So if I just take the sum, then this is nothing but equal to SUM of so you can do this summation and you can divide it by 44 instances, or straight away you can consider the average. So if I use average, then it is better. So here in the RMSE you have to just write SQRT. Now this SQRT is nothing but it square root the value inside the particular within it. So I have to just select the value, this value, and done. So you have RMSE value of 79. Now in the modeling, this is desired the RMSE value should be as low as possible. Okay. So next we will calculate the R square or coefficient of determination. So in that case you have to just find out the average of your observation. So why I'm just mentioning it now in the based on the formula. So let's say I'm just writing down the formula for it. So r square is nothing but it is the expression of or ratio of your original or predicted value minus mean observation square divided by observation value minus mean observation square. And for each instances you have to just sum them. So SUM. So I will create one column which is dedicated to observation minus mean. Minus mean. Another is predicted value. Okay, so I have to create square. So observation value minus mean value, square of it. Another is predicted minus mean square. So in this case, you have to just find out the mean of the data. So that value need to be calculated over here is equal to average so that is 64.24. Now here I will apply formula 84 minus, okay, so it's my mistake, so I calculated wrong mean, so I have to calculate here. It is average of this column, which is your observed value. So it will be 104 minus this value. Again, you have to just fix this because for every row the same value will be used to calculate this difference or deviation. Then just drag it. Similarly, for predicted value also you do the same. Minus again F47 and then you have to just take the square of this. And both cases you have to calculate the sum. So I'm just mentioning over here average, and this value is sum, and this, okay, here's just sum equal to SUM and here also it is sum. So now what we have to do, we have to just divide these two things. So that will equal to this sum divided by this value equal to. Now you got this r square value is 0.53. So now what is the interpretation of these numbers? So let me just color these values, as these are useful information from your model. So now if you just check these coefficient values of your regression b1, b2, b3 and b4, they are nothing but kind of a weightage of each predictors or each independent variables or your features. So now as per these values, you can consider that b1, that budget actually plays a most crucial role in case of prediction of your box office collection. So it has highest impact on it, 1.3423, and it is positive. So it indicates that higher the budget is, the better the predicted collection, box office collection is. Now the next best variable is your dislike. Somehow if your movie's trailer dislike is higher, then there is a chance that you earn more in case of this box office. And third important variable is indicated by the b3 coefficient, that is again related to YouTube likes, which is nothing but 0.003. And your YouTube views, they have very less importance, that is again 0.00045 for 1, means in the level of in the order of 10 to the power minus 5. So it is very less impactful in comparison to other 3 variables. Now what this r square indicates? This r square indicates that these 4 variables, your budget, YouTube views, YouTube likes and YouTube dislikes, they actually can explain 53% variability in the box office collection. And again same time this r square value can be considered as the accuracy of prediction. So means we can consider that this model can predict 53% accurately in the case of predicting the box office collection, or you can say the other thing, that the model can predict the box office collection in the range of 53% more accurately. So remaining 47% maybe can be incorporated by introducing more useful variables. In that case you have to just investigate more and you have to collect more features or incorporate more features in this modeling. So this is the end of your regression modeling.